Good day everyone. We, Frizzell May Segovia, are assigned to report the topic all about sampling procedure. So at the end of this lesson, you should be able to widen your English vocabulary, exchange the ideas with one another using the newly learned words, explain the meaning of sampling, familiarize with the factors affecting sample factors, or selection rather. 5. Compare and contrast sampling techniques. Find ways to overcome bias in sampling. Enumerate the pluses and minuses of some random sampling techniques. 8. Adopt the most appropriate sampling technique for a chosen research topic. And the last one, 9. Carry out a sampling technique with scientific value. Sampling means choosing from a large population, the respondents or subjects to answer your research questions. The entire population is involved, but for your research study, you choose only a part of the whole. Sampling means selecting the group that you will actually collect data from in your research. For example, if you are researching the opinions of students in your university, you could survey a sample of 80 students. The word population is a technical term in research, which means a big group of people from where you choose the same sample or the chosen set of people to represent the population. Population is the entirety of the group, including all the members that forms a set of data. Sampling frame, on the other hand, is the list of the members of the population to which you want to generalize or apply your findings about the sample. And sampling unit, on the other hand, is the term referring to every individual in that population. The sampling as well as the research results is expected to speak about the entire population, unless this does not refer to the population in general. The sample selection procedure has no scientific value. Factors affecting sample selection. In choosing your respondents, you do not just listen to dictates of your own mind, but also to other factors such as the following. Number 1 is sample size. Sample size refers to the number of participants or observations included in a study. This number is usually represented by letter N or N. The size of a sample influences two statistical properties, the precision of our estimates and the power of the study to draw conclusions. How big should the sample be? Some researchers base their decision on their own experience and research studies they have already read. But the best way to guide you in determining the right sample size is the representativeness of the sample with respect to the population. See to it that the sample truly represents the entire population from where the sample came. The representativeness or accuracy of a sample size is really hard to determine. However, using the right sampling technique such as a randomized one, your chances of getting a sample select or reflecting 95% distribution of the population of a sample representing the whole population is highly probable. Number 2 is sampling technique. Sampling techniques fall under two categories, the probability sampling and non-probability sampling. The first one uses a random selection. The second, a purposive or controlled selection. Probability sampling that gives all population members equal opportunity to be chosen as a people to constitute the sample is a precise way of sampling. Based on pure chance, it is an unbiased or accurate manner of selecting the right people to represent the population. In statistics, the sample method or sampling technique is a process of studying the population by gathering information and analyzing that data. It is the basis of the data where the sample space is enormous. Bias is the leading factor in choosing your respondents. This is one of the causes of sampling errors. The sampling other errors in sampling are attributed to your procedure in sampling. Number 3. Heterogeneity of population. Heterogeneous population is composed of individuals with varied abilities. Heterogeneity in statistics means that your population, samples, or results are different. It is the opposite of homogeneity, which means that the population, the data, or the results are the same. A heterogeneous population or a sample is one where every member has a different value for the characteristic you're interested in. There is a wide variation among the people composing the population. If it is a homogeneous population where lots of uniformity in abilities exist among population member, a sample of one will do. But for a heterogeneous group, a sampling technique that will widely spread the choosing of a large sample among all members of the population is necessary. Number 4 is statistical techniques. Statistical methods or techniques involved in carrying out of a study include planning, designing, collecting data, analyzing, drawing, meaningful interpretation, and reporting of the research findings. The accuracy of the sample depends also on how precise or accurate your methods are in calculating the numbers used in measuring the chosen samples or giving a certain value to each of them. Any error in your use of any statistical method or computing numbers representing the selected subjects will turn in unfounded results. Five is time and cost. Choosing samples makes you deal with one big whole population, with each member of this large group needing your attention, time, and effort, let alone the amount of money you will fork out for the materials you will need in making the sampling frame. Hence, considering all these things, your sample selection makes you spend the same of your time, deliberating or mulling over several factors affecting or influencing your sample selection. Sampling methods. The sampling methods are of two groups which are as follows. One is the probability sampling. This is a sampling method that makes you base your selection of respondents on pure chance. In this case, everybody in the population participates. Probability sampling refers to the selection of a sample from a population. When this selection is based on the principle of randomization, that is random selection or chance. Probability sampling is more complex, more time-consuming, and usually more costly than non-probability sampling. However, because units from the population are randomly selected, and each unit selection probability can be calculated, reliable estimates can be produced and statistical inferences can be made about the population. All are given equal opportunity or chance to form the sample that is capable of reflecting the characteristics of the whole population from where such sample was drawn. The following are the different probability sampling techniques. The first one technique is simple random sampling. Choosing a respondent based on pure chance. A simple random sample is a set randomly selected subset of a population. In this sampling method, each member of the population has an exactly equal chance of being selected. For example, You assign numbers to the members of the population and then use draw lots to obtain your sample. It is called a simple random sampling because it is drawn a lottery. Letter B is systematic sampling, taking out from that list every fifth or every eighth member listed in the sampling frame until the completion of the desired total number of respondents. Systematic sampling is a probability sampling method in which researchers select members of the population at a regular interval or K, determined in advance. So for example, you are given a list of all graduating students in your school. You decide to survey every 10th name on the list and ask in which organization they belong. It is called systematic sampling because the researchers select members of the population at a regular interval. Letter C is stratified sampling, choosing a sample that will later on be subdivided into strata, subgroups, or sub-samples during the stage of the data analysis. In a stratified sample, the researchers divide a population into homogeneous subpopulations called strata, the plural of stratum, based on specific characteristics, example, the race, the gender, identity, location, and etc. Every population of the population studied, or every member of the population studied, should be in exactly one stratum. For example, you wish to make a comparison about the gender differences in mathematics performance. You divide the population into two groups, male and female, and randomly pick respondents from each of the gender. It is called the stratified sampling because the researchers divide a population into a homogeneous subpopulation called the strata. They divide it into how many? Letter D is cluster sampling, selecting respondents in clusters rather than in separate individuals, such as choosing 5 classes of 40 students, each from a whole population of 5,000 students. In cluster sampling, researchers divide a population into smaller groups known as clusters. They then randomly select among these clusters to form a sample. Cluster sampling is a method of probability sampling that is often used to study large populations, particularly those that are widely geographically dispersed. Researchers usually use pre-existing units such as schools or cities as their clusters. For example, you randomly pick 5 out of 15 barangays to where to conduct your survey in your municipality or cities. It is called the cluster sampling because it studies the large population, particularly those that are widely geographically dispersed. Examples, the pre-existing units such as schools or cities as their clusters. Ensuring a bias-free selection of subjects, these probability sampling techniques are considered by many as more capable than the non-probability sampling techniques in coming out with accurate or exact samples to give pieces of information about the population as a whole.
Non-probability sampling. The sampling techniques included in this category are not chosen randomly, but purposefully, not randomized. They are susceptible to bias, unlike the non-probability sampling techniques that include the researcher judgments. The non-probability sampling techniques succumb to the control, likes, or wishes of the researchers and restrictions imposed by the researcher on the sampling procedure. The following are the non-sampling techniques. First is the quota sampling. Choosing specific samples that you know correspond to the population in terms of 1, 2, or more characteristics. The second one is the voluntary sampling, selecting people who are very much willing to participate as respondents in the research project. Third is the purposive sampling. Choosing respondents who you have judged as people with a good background, knowledge, or with great enthusiasm about the research. And the fourth is availability sampling, picking out people who are easy to find and locate and willing to establish contact with you. And the last one is snowball sampling, selecting samples from several alternative samples like drug dependence, human trafficking, street children, or other wayward and homeless people whose dwelling places are not easily located. They are like nomads moving from place to place. Random sampling vis-a-vis statistical methods. The most preferred sampling techniques in qualitative and quantitative research is random sampling. However, this kind of probability sampling requires the use of statistical method in measuring the sample. Three probability sampling: simple random, stratified, and systematic, depending greatly on statistics for sample accuracy. The use of statistics does not only prevent you from favoring any side of a things or situations involved in the research, but also proves the accuracy or precision of your sampling procedure. Contributing to the accuracy of sampling through the use of statistical methods in stratified sampling is use adherence to following steps in these unbiased sampling techniques. First, decide on the size of the sample. Second, divide the samples into subsets or subgroups, with the subsample having the same aggregate numbers as that one of the sample they came from. Third, select the appropriate subsample randomly from each subgroup or stratum. And the last but not the least, put together the subsample results to get the total number of overall sample. Advantages and disadvantages of 5 basic sampling techniques. So the first one here is random sampling. The advantages here is researchers choose simple random sampling to make generalization about a population. Major advantages include its simplicity and lack of bias. Among the disadvantages are difficulty gaining access to a list of a larger population, time, cost, and that bias can still occur under certain circumstances. Here is the stratified sampling. The advantages here is assure a large sample to subdivide on important variables needed when population is too large to list, can be combined with other techniques. So the disadvantages is can be biased as strata are given false weight unless the weighing procedure is used for overall analysis. Okay, next is the systematic sampling. The advantages here is similar to random sampling, often easier than random sampling. And the disadvantages here is sometimes permit bias. Next is the cluster sampling. The advantages is easy to collect data on the subject. And the disadvantages here is prone to bias when the number is small. And the last one is the quota sampling. Available when random sampling is impossible, quick to do. And the disadvantages here is presence of bias not controlled by the quota system.
This is Patricia III Espumalo, wishing you all for the best. Thank you for watching.
And I am Frizo May Segovia. Have a good day. Thank you.